Good day, ladies and gentlemen. Welcome back to the foundry. This is just a follow-up on the wind or hand wheel project that I was working on. Yesterday, let's see, this is the 1st of November. Yesterday, Halloween, in the morning time, just before noon, I went and poured that mold. Brought it up to pretty good melting temperature. It turns out probably just a touch hot. But it won't it won't really mess up the hand wheel that I poured. I mean, it's not like it's going to be a gear inside of a big machine. It's just going to be handled by the hands, by somebody tightening the vise. Okay. Anyway, so here, right over here, is the product. Now this is the original. This is what I used to ram up with. If you're not familiar with the project, and here's how it came in. Okay, you see how small that is? Look at all that over there that all got poured by this small sprue. All right, for those of you who use sprues this freaking big, it's not necessary. All right, not necessary at all. So everything was poured just fine. You can see from this angle, it's falling apart. Falling down. Anyway, from this angle, came down, filled in the runner first. When that backed up, this was open for it to flow, and I aimed each one of these ingates towards the hubs, or rather the spokes, which goes to the hub, so that once this got filled up, this would be able to push its way into here. Now the odds are good that while this was filling up, this was probably already being filled. Direct pressure going this way, it would have done that. But anyway, so I had very little room. If I had done this in the drag, I probably would have used up so much sand it wouldn't have been nearly as predictable what the outcome would have been. But it's made. Okay, this is the riser that filled in this hub section, fed it. And what I'm going to do now that you've seen how it comes out, oh, and by the way, look at all this up here. Okay, that's a bunch of sand and such that floated because the sand, keep in mind, silica sand is less dense than aluminum. Okay, so it's not going to shoot to the surface as if the silica sand was in with brass and bronze. But if you have this being poured right, it's going to be suspended in the molten metal, and its natural tendency is going to be to want to come to the surface like a sliver of wood inside of a bucket of water. Okay, so that stuff floated up to the top, and it should work good. So what I'm going to do now is I'm going to go ahead and get my bandsaw right there, put it in the vise over there, and start chopping all this excess metal off. Once I get to a certain point, I'll go ahead and turn the camera back on so you can see how I've progressed. And when it's all done, I'll turn the camera on again. All right, we will see you later. This is where we're standing right now. I've got everything chopped off except for the ingates, and then once I chop that off, I'm going to take off as much of that riser as I possibly can, and Keith Rucker will have to machine down the rest of it, because he's got all the good machinery up there. All right, be back in a sec. Pardon me. Here's the hand wheel. Chopped off the riser. As you can see, it fed real well. There isn't any shrinkage to be seen in here. And as you can see over here, there was a little piping here where it goes down in. So that fed very nicely. And so all this excess material, like here and here, I'm not going to get any much better than here. But I expect Keith would probably like to have this anyway to be able to chuck onto. But so my next steps is to clean all the excess metal off, wire wheel it, and after that it should be ready for send up to Keith Rucker up in Tifton, Georgia. Okay, we will see you after I get this done. Okay, before I get any further, see how far I've gotten so far. Okay, I just wanted to point out that I really wish I hadn't hit this with a hammer again to knock the sand out of these holes, but I mean, Gorilla Glue will only get you so far. But actually it helps a little better because remember, I'm using this, the original, as a pattern, okay? And you got to be particularly careful when you do that, that you wrap it and give a little bit more dimension inside the mold, so that when the item, or rather the material that you're pouring, when it shrinks, that it'll at least get really, really close, if not right on, the original, okay? And usually in a industrial sense, you usually only use this, the originals that are broken, if you don't have a pattern or if there's a particular case of having to get it done really fast, or they only want one, and you can make one, you know, no biggie. But for an example, the shank, or the hub, better called the hub, appears to be right on. Okay. And the ring that you actually grip, trying to get this lined up, appears to be right on. I mean, if I put a outside pair of measuring devices, and I mean, I'd probably have it just a little bit under 32nd of an inch or something like that. But just goes to prove you can use the original to make a new one, okay? If you haven't got access to a pattern shop, if you are only going to make one, or if you have to have it done in, you know, really quick, and the people that you're making it for are willing to take what you can make, okay? Because it's not going to be as good as when it comes out of the big factories that use permanent molds, that, you know, and they're not using sand anymore. Permanent molds, by the way, are molds that are made out of like stainless steel that they don't cast into the shape that they need. They machine it out, like you know, CNC machining, or back in the old days by hand machining. Once they get done with it, the inside skin of that permanent mold, you know, is smooth, nice and smooth. So no other skin can be expected other than a nice smooth skin. But if you use sand, you're not going to have a smooth skin, but you're going to have the casting, and you're not going to be paying $50,000 for the permanent mold. Okay, so put this back on the shelf, and I'll be back with you in a bit. I'm back. I think I'm back. Yes, I'm back. Okay, here's my finished product. Now, keeping in mind that everything has a little defect when you're making it, but this came out good. It'll be strong enough to be able to lock that, or close that vise. He won't have to try and braze the other one together. And, you know, a new casting, or a nice sound casting. If anybody knows what a sound casting sounds like. Hey, I could make a bell out of this stuff. Sounds good. Maybe that'll be a project in the future, because casting a bell it's that easy. Okay, you got to be very careful. Anyway, it's nice and solid, despite the small shrink I have right here. Okay, if that bothers you, Keith Rucker, if you're watching this, and I hope you are, don't very much think that that's going to have much effect on your tightening it when you tighten this stuff by hand. But I'd fill it in. You know, if you know how to TIG weld, I'd fill that in just for cosmetic reasons. I took some of the rougher stuff off the top of this, but I very much doubt that you ain't gonna put this in the lathe and turn this down, get it nice and smooth, and smooth that off so you can drill your hole. Now, I noticed something. Well, it goes without saying, you can notice it easily on something that's been used for probably decades, many decades. But you may not have looked at it this closely, Keith. That pin, obviously a tapered pin, okay? See on the small, I sure hope I got enough light in there. On the small end, no wear and tear. However, on the big end, looks like it's been doing a lot of wear and tearing, and it's even got score marks on the inside. Doesn't look like the inside of the shaft there that it's all wore out. It still looks like it's got a sharp edge from when the hole was drilled. But you know as well as I do, aluminum doesn't take the wear and tear that this does, so you're going to have to compensate for that. My idea would be, because of the where the ends of the pins are going to be, and it shows that the end of the big end of the pin got the most, wear and tear. Maybe this big end wasn't big enough. Okay, well, it didn't fit properly. I don't know. But on this ain't gonna last. I mean, it's gonna the holes are gonna be rounded out or got ovalized, probably only after about 3 or 4 years. So if I were you, Keith, with you having all the stuff there to be able to do it, I'd take this down and down to where you make yourself a high wearability or a very hard piece of steel, and press it on there. Make a sleeve to go on this so that the aluminum won't get distorted, and the sleeve out here will keep the pin from rattling inside, because you're going to be making it. I mean, the odds are good that you're going to be making the pin and the holes. Heck, you're probably going to get it just to the right size where this wearing isn't going to be a problem for quite some time. So, but that's my suggestion. That's as far as I could go on this side. My saw wouldn't come any closer to that. But thankfully you've got a lathe that you can bring it down like that to that surface. And you'll notice that, sorry for getting you dizzy, hope you didn't get too dizzy, that the the casting is pretty much the same size as the old one. So you're not going to have to compensate for anything on that. So sometime this week I'll get this sent out. It's been fun making it. I hope it's been fun for you guys watching. And heck, what was it? My mistake. Okay, this is my fault. I didn't double check the temperature on this aluminum before I poured it. If I had of, that shrink wouldn't have been there. But in this case though, it's basically, you know, it's just for looks. You know, it just don't look good. Plus, by the time this gets put in place, you're not even going to see it anyway. If you don't want to put anything in there, Keith. For that matter, if you want to just make it look good, you could probably just put some solder in there. Just surf it. That really wouldn't do anything. It wouldn't add to the strength of it at all. And the amount of strength that it would ever gain by you tigging it probably wouldn't be measurable. Just for looks. Okay? This has been a fun little project. Just to show everybody out there that's watching these, you could take an old casting that's been busted, especially cast iron, because you can just drop this and it'll shatter. Well, right out of the pattern. I mean, right out of the mold. You take a casting that's made out of cast iron, you drop it accidentally on the floor, it's going to break like glass. Okay, so, and with any casting that you have coming out of the sand, all of the castings, every one of them, are going to have a certain amount of stress involved because of the differences in grain size. And well, that was formed when it was shrinking, okay, or solidifying, I mean. So this has been fun, like I said again. So everybody out there that is thinking of making these, now you know how to, or at least one way. All right. Thanks for, well, watching. I enjoy it. See you next time, and Liberty Call. It's an earthquake.